In this video, we're going to go over arithmetic and geometric mean. So firstly, let's look at, let me write it with something visible. Let's look at arithmetic mean. So the arithmetic mean between two numbers. So if I tell you I want to calculate the arithmetic mean between A and B, then I'm trying to find the value capital A between A and B such that when I put A in between my small a and when I put capital A, so let me just say I have two numbers, A and B, and I want to find their arithmetic mean. So I want their arithmetic mean is defined to be the value that when I put in between A and B, it forms an arithmetic sequence, right? It should form an arithmetic sequence. So this is the arithmetic mean. And it is the number that when I put in between A and B, that enables me to get an arithmetic sequence out of things. So that is my arithmetic mean. So basically the idea is that C should be equal to A plus D, right? So A plus some common difference should give me C. And the same C should be equal to B minus D. So it should be D less than my common difference less than B, and it should be D greater than my A starting value. So you see that 2C is just, if I add these two equations together, 2C is just A plus B, because plus D and minus D cancel out. So C is A plus B divided by 2. So C, the arithmetic mean between two numbers, is basically their average. And when we calculate averages, that's what we are doing. So if we're given n numbers, A1 plus A1, A2, A3, all the way up until AN, then their arithmetic mean would be this expression. So that is the arithmetic mean of n numbers. And yeah, basically arithmetic mean is the number that you want to put in between the two given numbers. So the arithmetic mean of two numbers is the number that when you put in between those two numbers, it forms an arithmetic sequence. And we apply the same idea. So I hope you remember the general formula. So we apply the same formula idea to a geometric mean. So a geometric mean. So geometric mean is basically you have two values again, A and B, and let's call their geometric mean G. So a geometric mean is the value that you want to put in between A and B such that these three numbers now form a geometric sequence. So their mean, so A times some common ratio R has to be G, right? And B divided by the common ratio should give you G as well. So dividing by R here gives me G, and multiplying by R here gives me G. So now R is the same thing, so I can compare. So I know that G divided by A is equal to R, and from this expression, I know that B divided by G is equal to R. So therefore, G divided by A is equal to B divided by G. G squared is equal to AB, or G is just square root AB. So this is the geometric mean between two numbers. It is the number that when you put in between those two numbers forms a geometric sequence. And if you're given n terms, then their geometric mean is just defined as A1 times A2, A3. So you multiply up until AN, and then you take their nth root. So this is the geometric mean. And the arithmetic mean is always bigger than or equal to the geometric mean for a set of numbers. And yeah, I think that is about everything you need to know. So you want to remember this key point, you want to remember the formulas, and I believe you're ready to start some questions. Alright, so determine the arithmetic mean. That's just, you add the two numbers together, divide by 2. A1 plus A2 divided by the number of terms, which is 2. So 6 plus 23 divided by 2. So that is 29 by 2. That, I believe, is 14.5. So that is their arithmetic mean. So let me just check as we go. It's 14.5. All right. And B is this expression. So you want to do the same thing. It's P minus Q squared plus P plus Q squared divided by 2. So that is, if you expand the first, so if you expand this out using the binomial expansion, you get P squared plus Q squared divided by 2. So that is what you are going to get. Sorry, you're going to get 2P squared plus 2Q squared divided by 2. So this simplifies to p squared plus q squared. So let me just show you how. If you expand the first term, you get p squared minus 2pq plus q squared. If you expand the second term, you get p squared plus 2pq plus q squared divided by 2. So p squared plus p squared gives you, sorry about that, p squared plus p squared gives you 2p squared. The minus 2pq and plus 2pq cancel out, so you have plus 2q squared divided by 2, and that is just p squared plus q squared. So that is the answer for part B. Alright, part C, we have this expression. Cos A plus sin A squared, and cos A, I think they want minus sin A. That would make more sense. So I think this is a typo. So it should be minus sin A squared. So basically, it's just cos A plus sin A. You take the first term, you add the second term, and you divide by 2. So when you do so, when you expand the first bracket out, that is cos squared A plus sin squared A plus 2 sin A cos A, right? When you expand the first term out, when you expand the second term out, you get cos squared A minus 2 sin A cos A plus sin squared A divided by 2. Now, plus 2 sin A cos A minus 2 sin A cos A are going to cancel out. And you have 2 cos squared A plus 2 sin squared A divided by 2. And when you simplify, you get sin squared A plus cos squared A. And sin squared theta plus cos squared theta is always 1. So that should be your answer, but I think this is a typo. This should be a negative sign here. Alright, so we are done with question 1. Question 2. Find 5 arithmetic means between 4 and 22. So basically, this is telling me that I have some value 4 plus d, 4 plus 2d, 4 plus 3d, 4 plus 4d, and 4 plus 5d. So these are going to be my 1, 2, 3, 4, 5 means. And then I have my ending term is 22. Alright. And I also know that 22 is just my 6th term in this arithmetic sequence, right? So I can write 22 as 4 plus 60, following this pattern. So now I can calculate d. d is just 3, right? 22 minus 4 is 18 is equal to 6d, and therefore d is just 3. So now we can just substitute this value back here, and we get our 5 arithmetic means. So 4 plus 3 is 7, 7 plus 3 is 10, 10 plus 3 is 13, 16, and 19. So these are our 5 arithmetic means: 7, 10, 13, 16, and 19. Alright, so you want to use the idea of sequences again, and basically you want to calculate d and then get the arithmetic means. So now it's the same thing, but it asks us for 8 arithmetic means between 17 and 53. So I have 17, 17 plus common difference, 17 plus 2d, 17 plus 3d, on and on, 17 plus 8d, because I want 8 of these. And then finally, I have 53. All right. So 53 is just a continuation of the sequence. It's just 17 plus 9d. It's the next term. So now we can solve this. So when you solve this, 53 minus 17 gives us 36, 9d, and therefore d is just 4. And 17 plus 4 is 21, 25, 29, 33, 37, 41. So these are going to be our means, 45 and 49. So you just want to substitute for all the expressions we have here. You want to substitute the value of d and get your means. So it starts from 21, increments by 4 every time, and you stop at 49 to get your 8 arithmetic means. Alright, and you want 3 arithmetic means in this thing. So basically, you want these to form an arithmetic sequence. So you can subtract 4y, the next term, minus the previous term, 3 plus x plus 3y. This has to be your common difference, right? You shift by d, you add d, and you go on. So So your common difference, 4y minus 3y, is y minus x. That is your common difference when you simplify this expression. So now, your first term is just gonna, your first blank is just gonna be 5y minus x plus your common difference. So 5y minus x plus y minus x gives me 6y minus 2x. So that is my first arithmetic mean. My second arithmetic mean is 6y minus 2x. To go to the next blank, I need to add d again. Plus y minus x is equal to 7y minus 3x. And for my last bracket, I need to go one more. Plus y minus x. And that gives me 8y minus 4x. So these are our three arithmetic means. Alright, we're done with question 2. Question 3, find the geometric mean between 7 and 63. So the geometric mean is just the square root of the product of these two numbers. Based on the formula, remember, g squared, geometric means between a and b, is just a times b. So g is just square root of a and b. And in general, if you have n terms, then you multiply the n terms together and you take their nth root. So the geometric mean is just square root of 7 times 63. And when you use your calculator to figure this out, that is 21. And 3, 9, and 27. So the geometric mean between these three numbers is the cube root. You multiply the numbers together, so you have three numbers, and then you raise it to 1 over 3, because you have three numbers. So a1 times a2 times a3, and then the power is 1 over n. So in this case, n is just 3. Alright, so you have 3 times 9 times 27 to the power 1 over 3. And that just gives us 9. So your answer is 9. Alright, question 4. Find three geometric means between 16 and 256. So we start with 16. We multiply. So this is a geometric sequence. You multiply by some common ratio. 16 times r, 16r squared, and 16r cubed. And then finally, because we want three of these, we get to 256. But remember, 256 just has to be 16r to the power 4, right? This pattern has to continue. So now we can calculate the value of r. So 256 divided by 16, r4 is just 16. So r could be plus or minus 2. Remember, 16 is just 2 to the power 4. So r is plus or minus 2. And using our value of r, then our three geometric means could be, so if I use positive 2, then it's 32, 64, and 128. Or it could be negative 32, 64, and negative 128. So these numbers could be the three. So if you think about it, we only want to take the positive r. So we only want to consider it as an increasing geometric series. So we wouldn't take negative 2 because that won't satisfy the definition. So you want to take all your positive values. So in this, when we talk about geometric mean, we usually consider it to be positive. Alright. And you want 5 geometric means between 1 and 64. So you start with 1, you multiply by r squared, r cubed, r4, r5. Those are our 5 means in between, and you get to 64. And 64 just has to be r6, right? You multiply by r again. So r is just, I believe 64 is 2 to the power 6. So r is just 2. So therefore your numbers are 2, 4, 8, 16, and 32. So you only want to take positive values of r. So you only want to consider a positive geometric mean. Alright. Because you're taking the square root or the cube root. So usually you want to take the positive mean. So you won't take, so the negative values, although r could be negative in some cases, those won't be considered as geometric mean. because we're taking the nth root of something, and usually the nth root of something is positive. So we only consider the positive values. Determine two numbers that multiply to equal to 91. So basically, let's say our numbers are a and b. So a times b is 91, and their mean is 10. So a plus b divided by 2 is 10. Arithmetic mean just means that my two numbers, when I add them and divide by 2, I get 10. So if I multiply by 2 on both sides, a plus b is 20. And I know ab is 91. So a is just 20 minus b. And I can substitute this information here. So 20 minus b times b is just 91. So 20b minus b squared is equal to 91. And if I take all the terms here, I know that b squared minus 20b plus 91 is equal to 0. And if I solve this equation, then b is just 20. So I'm going to do it very quickly. 400 minus 4 times 91. So 364. So this is actually just going to give me 6 inside my surd, inside my square root, all over 2. So I have b is equal to 13, or b is equal to 7. And so 13 times 7 is 91. And the arithmetic mean is 10 because they both differ by 3, right? And now, because I have two values of b, then I'm going to get a is equal to 13 or a is equal to 7. So I just substitute it here. So therefore, if b is equal to 13, then a is equal to 7. You see that? Or if b is equal to 7, a is equal to 13. So your two numbers are 13 and 7. All right. Question 6. If r number of arithmetic means are inserted between x and y, prove that the common difference is this expression. All right. So we have x, and then we're adding r terms in between, r arithmetic means. So the first mean would be x plus d, x plus 2d, x plus 3d. So we're adding r of these. So our last arithmetic mean has to be x plus rd, because the coefficient in front of d is working as our counter for the arithmetic means. I'm so sorry about that. So now we know that y is just x plus r plus 1d, right? That is just y. And using this, so basically our next term, so when I add one more d here, I should be getting my next term. And when I do that, I get this expression. And therefore, r plus 1d is just y minus x. And d is just y minus x divided by r plus 1. And that is exactly what we're